Good evening, everyone. Yesterday we have done up to 20th problem, right? Today, let me discuss the remaining. I am going to share the screen. 21st problem on the screen. Observe. Yesterday we went through that 20th problem. How many onto functions can we write from A to B? Right? Number of onto functions from A to B 2 power n minus 2. In this 21st problem, the number of into functions that we can write from capital A, which consists of 5 elements, and capital B, which consists of 3 elements. So, how many into functions can we write from capital A to B? You can use the synapsis called n to the power of m minus n minus 1 or nc1 into n to the power of m n minus 1 to the power of m plus n minus 2 or nc2 into n minus 2 to the power of m and so on. Then you are going to get the number of into functions is equal to 93. Right? So, write down n to the power of m minus nc1 into n to the power of n minus 1 to the power of m. I am repeating 21st problem. Observe. M value is equal to 5. M value is equal to 6. Why? Because n of a is equal to 6 and n value is equals to 3. I think. Wait for a while. N is equals to alpha, beta, gamma. I wrote n value as m is equal to 5 here and n value is equals to 3, alpha, beta, gamma. You use this formula n to the power of m minus nc1 into n minus 1 to the power of m plus nc2 into n minus 2 to the power of m and so on. We are going to get the answer. Right? Now, next problem. Observe that 23rd one on the screen, 22nd one on the screen. Number of many one functions from capital A means n of A consists of only 3 elements. Number of B is equal to only 4 elements. Right? Total number of many one functions is equal to n to the power of m minus npm. Use this one, we are going to get the answer. N to the power of m is equal to 4 cube minus 4p3. Right? 4 cube is equal to 64 minus 4p3 is equal to 4 into 3 into 2, which is equal to 24, which is equal to 40. Now, problem number 23. N of A is equal to n. A consists of n elements and B, n of B, number of B is equals to 2. Therefore, he asked you total number of constant functions. At the time of functions, I discussed that number of constant functions, from capital A to B is equal to n of B itself, which is equal to 2. You copy these three problems, right? And afterwards, let us discuss the problems on alike things. Yeah, copy these three problems answers. Right? Copy those three. Next problem, problems on alike things. Problems on alike things. Okay, I am going to discuss the concept of alike things initially. After that, let us go through the problems on it. Among n things, listen, among n things, if p things are of one kind, q things are of second kind, r things are of third kind, then the entire permutations that we can write are n factorial by p factorial into q factorial into r factorial. I conclude the concept of alike things. Among n things, if p things are of first kind, q things are of second kind, and r things are of third kind, then the total number of permutations we can write from, that means we can form from it, that is in this problem it is n factorial by p factorial into q factorial into r factorial. By using this synopsis, we are going to do the problems from 24. Right? Observe that problem number 24. On the board. Yeah, observe that problem number 24. The number of different arrangements that can be made out of Mississippi, MI, SSI, SSIPI. So there are 10 letters. I am going to write that on the board. Observe 24th one. MISSIPI. Number of letters is equals to 10. We are having 10 letters here, right? Number of I's is equal to 4. Number of S is equal to 4, right? P is equal to 1. Therefore, required permutations are 10 factorial upon 4 factorial into 4 factorial. Right? This is the answer for that problem number 24. Now problem number 25. In problem number 25, what has been given to you? Observe. I am scrolling down. Yes, it is visible to you all, I think, right? Now, the number of ways in which 17 billiard balls be arranged in a row if 7 of them are black. Total number of balls given to you, n is equal to 17. Number of black balls is equals to 7. Okay. Number of black balls is equal to 7. Number of red balls is equal to 6. Number of white balls is equals to 4. Number of white balls is equal to 4. Required number of white balls is equal to 4. Required permutations are 17 factorial by 7 factorial into 6 factorial into 4 factorial. Copy this one. This is 25 and about 26th problem. Okay, copy up to here. Copy this one. Yes, I hope you have copied up to 25. Now I am going to share the 26th problem. Number of words that can be formed with the letters of the word correspondence. CORRESPONDENCE. You can count them. Of course, there are 14 letters. Observe. So 14 factorial. Number of E's is equal to 3. So you got 3 factorial, right? Now number of R's is equal to 2 factorial. number of d's is equals to, okay, only 1. Number of n's is equal to 2 factorial. Number of c's is equal to 2 factorial. Number of o's is equal to 2 factorial. That means total number of 26th problem, total number of letters is equal to 14. Okay, number of o's is equal to 2. Number of c's is equal to 2. Okay, number of n's is equal to 2. Number of e's is equal to 3. Okay, number of what it is, the letter word correspondence. Number of r's is equal to 2. Now, required factorial is equal to 14 factorial upon 2 means 2 factorial to the power of 4 into 3 factorial. You are going to get the answer. Copy that one. Yes, I hope you have copied it, right? Yeah, copy this one, 26th one. Copy that 26th problem. Now, I am going to share that 27th one on the screen, 27th one. Yeah, observe that 27th problem. Easily you can do that. Number of ways to rearrange the letters of the word cheese. CHEESE. So there are 6 letters, right? 6 letters can be arranged among themselves in 6 factorial ways by 3 factorial. Why? Because 3 E's are there. Take down 27th one. 27th one. I am repeating that 27th problem. 6 factorial. Number of letters is equal to 6. So 6 factorial by 3 factorial. Right? Now the next question, problems on, I think there is no need to write that 27th problem on the board because already you know it. I am going to discuss the problems on circular permutations concept. That means just listen the concept first of all. After that, let me do the problems related to circular permutations. Right? Arrangement of things circularly is called circular permutation. Means, suppose if you want to arrange any some dissimilar things, okay, around a circle or around a table, means accordingly as circular, then that is related to circular permutation. Okay, in circular permutations, n things can be arranged among themselves. N dissimilar things can be arranged among themselves circularly in n minus 1 factorial ways. N dissimilar things can be arranged. I am going to write it here specifically. Circular permutations, right? That means arrangement of things circularly is called circular permutation. N dissimilar things can be arranged among themselves in n minus 1 factorial ways. Whereas in our linear permutations, n dissimilar things can be arranged in n factorial ways. What is the difference between that one and this one? See here. This is called linear permutation, right? This is called circular permutation. In this one, you can arrange 4 members in 4 factorial ways. In this one, 3 factorial ways. May I know what is the difference between these two? In linear permutation, you will have the starting point and the ending point. You can count it. By suppose if I ask you to count, that means you are going to start either from here or here. So it will have a starting point and ending point where you can't identify the starting point and the ending point. If you want to count it, right, you should take 1 member and 1 seat. Means, suppose if I want to count, I can start counting from here, right? So there is no starting and ending point as it is the circle. Okay, so you should take 1 point fixed. Means, suppose 4 members are there. If you want to arrange 4 members around a circle, first of all, you should make 1 person to sit in 1 chair, right? There are 4 chairs around a circle. You should arrange them in, that means circularly. In how many ways you can arrange 4 members around a circle? See, as there are 4 members and 4 chairs, you should select 1 chair and 1 person. So, suppose if this chair and 1 person gone, there will be, that means that is fixed. Then there will be only 3 members. 3 members can be arranged in 3 chairs in 3 factorial ways. That means ultimately 4 persons can be arranged circularly in 3 factorial ways. Have understood now? Means n dissimilar things can be arranged circularly in n minus 1 factorial ways. Circular permutations are of 2 types. One is clockwise, another one is anti-clockwise direction. Right? Now, circular permutations are 2 different types. One is normal and another one is hanging type circular permutation. In normal permutation, n minus 1 factorial ways. In normal circular permutations, n things can be arranged among them in circularly in n minus 1 factorial ways. In hanging type circular permutation, n things can be arranged among themselves in circularly in n minus 1 factorial by 2 ways. Which are called as hanging type, sir? That suppose if you, in the question, if you have flowers, garland, chain, black beads, this type of words, then you can use this formula, right? Normal permutations means 8 members can be arranged circularly in how many ways? 8 minus 1 factorial ways, like that. Okay. This is about circular permutations concept. So I conclude the concept of circular permutations. The arrangement of things circularly are called as circular permutations. Circular permutation, n dissimilar things can be arranged among themselves circularly in n minus 1 factorial ways. Circular permutations are of two types. One is clockwise direction and another one is anti-clockwise. If it comes to hanging pair circular permutation, n dissimilar things can be arranged circularly among themselves in n minus 1 factorial by two ways. How could you identify it is a circular permutation? So flowers, garland, chains, black beads, when you have this type of birds, then you can use the formula of n minus 1 factorial by 2. Okay. Now let me share the problems related to circular permutations. Yes, now observe, I think you got the concept of circular permutations, right? Now, see the problems on circular permutations. 28th one. The number of ways can 8 students sit around the table are n is equal to 8. Therefore, n minus 1 factorial is equal to 7 factorial. Copy that one. I hope you can do. 28th problem. Write down 28th one. 28th problem. Right? 28th problem, he has given you number of ways can 8 students sit around the table. N is equal to 8. N minus 1 factorial is equal to 7 factorial is the answer. Now, let me move to 29th problem. Observe. Look at the problem number 29. The number of ways that 8 beads of different colors. Now itself I said, if you got the words like black beads, garland, right, necklace, flowers, and all those things related to girls, then it is said to be hanging type circular permutation, right? In the hanging type circular permutation, n value here it is given as 8, n minus 1 factorial by 2, which is equal to 7 factorial by 2. Take down 29th problem. right? 29th problem. Write down, given number of beats n is equals to 8. N is equals to 8. Therefore, number of ways of 8 beats be strung as a necklace n is equal to 8, n minus 1 factorial by 2. N minus 1 factorial by 2 is equal to 7 factorial by 2. Simplify that one, you are going to get the answer. And in the bracket, you should write hanging type circular permutation. Right? Now the 30th problem. Problem number 30. The number of ways can 11 persons sit around a table so that all shall not have same neighbors if any two arrangements is that means as the direction is not considered, it is also related to n minus 1 factorial by 2 ways. N is equal to 11. All shall not have same neighbors means you should, that means you should consider that entire as one unit. Instead, you can use the formula called n minus 1 factorial by 2. Right? So, n is equal to 11. N minus 1 factorial by 2 is equal to 10 factorial by 2. See that problem number 31. The number of ways in which 5 different colored flowers. You got the word flowers means it is called as hanging type circular permutation. Am I right? Hanging type circular permutation. Okay. So 5 different color flowers means n value is equal to 5. Be strung in the form of garland. So it is 5 minus 1 factorial by 2. It is 4 factorial by 2. 4 factorial value is equal to 24. 24 by 2 is equals to 12. I hope you have copied that problem number 31. Do that problem number 31. N value is equals to 5. N minus 1 factorial by 2. Is equal to 5 minus 1, 4 factorial by 2. Right? Now, observe the 32. The number of circular permutations of 8 things taken 4 at a time. Of course, I should discuss this on the board. At a time in both directions means you just see that problem number 32. I am stopping that sharing because board is not visible to you. Share like that. Now observe problem number 32. Eight things should be, that means 8 things are there. N is equals to 8 and R value is equal to 4, right? When that means in both directions, both clockwise and anti-clockwise, means both directions means NPR by R. Only one direction is equal to NPR by 2R. Now he asked you both directions. In that means in anti-clockwise and clockwise means 8P4 by 4, which is equal to, what is the value of 8P4? 8 into 7 into 6 into 5 by 4. 4 ones and 2s. Multiply this one, you are going to get answer. It is 420. Right? (32) is over. Now I am going to share 33 on the screen. Number of necklace of 8 beads. See the same thing. 8 beads. Each can be made 15 beads of various colors. N value, write down. N value is equal to 15. R value is equal to 8. Direction is not considered, means any one direction it is. So 15P8 by 2R. 2R is equal to 2 into 8, 16. 15P8 by 16 is the answer. 15P8 by 16 is the answer. Copy that one. 33. Problem number 33. Put N is equal to 15. N value is equal to 15. right? N value is equal to 15. R value is equal to 8. Therefore, when the direction is not considered, it is 15p8 by 2r. You should write npr by 2r. npr by 2r. Yes, I hope you have copied it right. Now, 34th problem. Sum of numbers without repetition. Problems on sum of numbers. See that problem number 34. The sum of all numbers formed by taking all the digits 2, 3, 4, 5. Actually, what is the meaning of the question? Yes. What is the meaning of the given question? He asked you to find out sum of all digits formed by 2, 3, 4, 5. Two, three, four, 5. See what is the meaning of it? See here. 2, 3, 4, 5. Okay. 2, 4, 3, 5. Okay. 2, 2, 3. Another one. See here. 2, 5, 3, 4. Okay. This is also 4 digit number, right? And 5, 2, 3, 4. Right. 4, 3, 2, 5. Like this. Means you should get all the sum of all numbers. So how to get it? It is not possible to write all the numbers. So you are having one shortcut way to find out this one. What it is? You consider this one as, see the solution. 1, 2, 3, 4. N is equals to 4. He asked you 4 digit number. So n minus 1 factorial into sum of all digits into 1111 n times. So this gives you the value. What is n minus 1 factorial? 3 factorial into sum of all digits 2, 3, 4, 5. In this problem, 0 is excluded. If 0 is there, you should take another one. Of course, if the problem comes, I will discuss. 3 factorial into this into n times means how many digits are there? 1, 2, 3, 4. So 4 ones. Simplify this, you are going to get the answer. 3 factorial 6 into 14, right? Into 1111. Simplifying this, you are going to get the answer. Copy this one. And if you have the material with you, even you can observe that in the synopsis also. Right? Now, take down the next problem. Problem number 35. Yeah, same model. The sum of all numbers formed by taking all the digits from 3, 4, 5, 6, 7. So n is equal to 5. Use the same formula because 0 is not there in the problem. Suppose 0 is included, suppose 0 is there, then you should use n minus 1 factorial into sum of all digits into 1111 minus n minus 2 factorial into sum of all digits into 1 1 1 1 up to n minus 1 times. I am going to write there, if 0 is there in the problem, if 0 is given in the problem, you should use this one. N minus 1 factorial into sum of all digits, right, into 1 1 1 1 and so on n times, minus n minus 2 factorial into sum of all digits, right, sum of all digits into 1 1 1 1 so on n minus 1 times. So when should you use this one? 0 is included in this problem number 35 and 36, that is 34 and 35. No, that is no 0 given to you. So you can use the same formula for the next problem also, right? Use the next same formula. N minus 1 factorial, 0 is not there, na? Into sum of all digits into 1 1 1 1 up to n times, right? And tomorrow, that is 35th problem formula. Tomorrow, let me discuss some more problems on it, dearrangements. Thank you and have a nice evening.